Hi guys, and welcome to this video here with regards to correlation and causality. This is a great little video. It's relatively quick. A lot of me talking, sadly, very few examples, but there are VCAR exam examples coming up. Now, we've done a lot on correlation already. We've got Pearson's correlation coefficient. We've got the coefficient of determination. Life is really good. We're almost at the end of this series of videos. There's only one more to go, which is Witch Graph. Really, really short. If you haven't watched it, it's a doozy. Now, thanks very much for watching. If you haven't already done so, do me a favor and subscribe by clicking that little doohickey in the corner. It just let me know that you are watching. Nothing more exciting than that. Never going to be rich, never going to be famous, but just lets me know that people are watching and gives me a bit of a purpose for doing these videos. Otherwise, every now and again, I just give up because it's like, no one's watching. They're all watching cat videos. Otherwise, there's mathsguru.com. If you haven't found that, it's also free to sign up, where all the videos are linked and ordered by textbook, by chapter, and have downloadable notes. And as I develop more and more resources, it will all be uploaded on there, including exam solutions. Correlation and causality is really important to know that we have, in previous lessons, looked at this idea of correlation. All right, so Pearson's correlation coefficient is nothing more than a measure of how close those little kisses are to perfectly straight lines or not. It does not necessarily mean that there is a relationship between the two. Okay, it does not mean that one causes the other. All right, and that's probably the biggest word here that's most important. Does a change in one variable cause the change in the other? All right, so for example, I quite like this one here, ice cream sales versus the sale of hats. Believe it or not, if you were to draw a graph of ice cream sales versus the sale of hats, all right, so ice cream, we'll put there, and we'll put hats here. Believe it or not, you will get something that looks like that. A little surprising, because as far as I'm concerned, there is no way that the sale of ice creams can cause the sale of hats. It doesn't make any sense whatsoever, and yet actually that's what you'll end up. Maybe not as perfectly beautifully kissy straight as that, but not far off. What we would notice is that there is a very much definite upward trend in our data. Why? How can ice cream sales and hats have this level of correlation? Well, ladies and gentlemen, there is in fact a third variable. We'll come back to that in just a moment. But again, I know I keep going on about this, but correlation does not imply causality or a cause. All right? Just because two things have some sort of a correlation does not mean that they are in fact related or caused, that one causes the other. Okay, so important language for this particular exam, and this particular section, is there was three things. One, common response. Now, as I just said a moment ago, if we looked at that idea, oh, let's not draw in highlighter, I keep doing that. Oh, let's not draw it in purple either. If I look again at my ice cream versus my hats and those kisses, you have to ask yourself the question, is something else causing this increase? And yes, there is a common response. One other thing that links hats and ice creams together, and what would that be? Well, obviously ice creams, temperature. As the temperature goes up for ice creams, so will the number of ice creams sold. As the temperature goes up, what are people going to buy more of? Probably hats, particularly in Australia where you have to be sun smart. So in this situation, we would say that temperature is a common response. And for lots of sort of correlations between two different variables, there may be just one common response. And you have to think about this. The problem with sort of the exam is they may throw questions here that will ask you to sort of have some wider understanding of the world. In a previous video, I asked you to go and Google the Human Development Index. Always useful to know what that one is for further maths. But sometimes in further maths, we write questions that just ask you to think and give your opinion. It's not all plonking into a calculator. Please be the calculator and sort of just spitting down what the answer is. So that's a common response. Then there is something called confounding variables. Now, a common response is one particular link. All right, so in that previous situation, we had temperature. So temperature caused the increase in ice creams, temperature caused the increase in hats. Probably nothing else would cause that. But if we were to look at crime rates and unemployment, all right, if we were to look at crime rates and unemployment, well, again, we would probably see that as unemployment goes up, then crime rates go up. There would be some sort of correlation between those two. But is there just one thing that causes the increase in crime? Is there one thing that causes the increase in unemployment? And are they the same thing? Absolutely not. To be fair, there are all sorts of reasons for crime. It's not just linked for one thing. So for example, it may well be, as we say here, the state of the economy. So the state of the economy was perhaps responsible for change in unemployment. At this moment in time, we are going through a most horrendous thing with this COVID-19 thing. And it is horrendous that lots of people are losing their jobs. They're being stood down. It is actually quite scary for a lot of people. So our unemployment figures will obviously be going up. Will our crime figures be going up? Maybe. Is it going to be the fact that because more people are now unemployed, they're all going to go and steal stuff? Not necessarily. The economy might have been responsible for the change in crime, but we don't know by how much. So when there is more than one thing that could be looking at causing this correlation between, then we say that they are confounding variables. A couple, two or three would be enough to sort of suggest, oh, it's not just one. And then, ladies and gentlemen, there is a complete coincidence. Now, if you've seen the previous video, one of the things we came to was a VCAR question talking about coincidence. And believe it or not, there is, and this example is taken from the Cambridge Further Maths textbook, thank you Cambridge, a suggestion that there is a 0.99 correlation. Now, that's almost perfect between the consumption of margarine and the number of divorces in the state of Maine in the USA. OMG. All right, so a 0.99, that is almost perfect correlation between the consumption of margarine, which is like butter, and divorces in Maine. There is absolutely no way that the consumption of margarine can have anything to do with the divorce rate, unless people are getting so incredibly large that unfortunately their marriages fall apart. Highly unlikely, subjective, and a little bit controversial, but anyway, we'll leave that one there. So sometimes there may well be just a complete coincidence. And believe it or not, ladies and gentlemen, that is the end of this particular lesson. I'm going to do a couple of VCAR questions which are semi-related to this, but you just need to realize that there are those three terms: coincidence, confounding variables, and common response, to try and link to what is going to be done for our exam questions. All right, that's it. VCAR exam 2017 paper 1, data collected over a period of 10 years. Now, there's a lot of text in this question. Indicated a strong positive association between the number of stray cats and the number of stray dogs. So there's cats, there's dogs, and a strong positive correlation suggests something along those lines. A positive correlation was also found between the population city and both the number of stray cats and the number of stray dogs. So we had population and cats, which was 0.61, so that's going to be fairly wide, but there. And what did we have? The other one was dogs. The population, and that was 0.72, which was a lot closer. So do you have to draw a sketch for this? Probably not. I am, just to give me sort of an idea of what we're doing. But one of the great things is, I'm looking at this question going, yeah, this is about causality or causation or something along those lines, we'll see. During the time the data was collected, the population of the city was growing from 36,000 to 51,000. Okay, from this information we conclude that A, if cat owners paid more attention to keeping dogs off their property, the number of stray cats reported would decrease. Stupidest answer I have ever read in my entire life. Okay, what has that got to do with the price of fish? Cat owners paid more attention. No. B, the association between the number of stray dogs and stray cats reported cannot be causal because only a correlation of +1 or -1 shows causal relationships. Absolute rubbish. A causal relationship does not have to be +1 or -1. It can be any value whatsoever. Rubbish. But this again points to, do you understand the concepts that we're talking about here? Yeah? Alternatively, just guess. C, there is no logical explanation for the association between the number of stray cats and stray dogs reported in the city, so it must be a chance occurrence. Okay, so chance, maybe. Could it be a chance? Let's just put a little question mark there. D, because larger populations, hold on a moment, we're talking about populations here, tend to have both a large number of stray cats and stray dogs, the association between the number of stray cats and stray dogs can be explained by a common response to a third variable. Pretty much this whole question, I think, was trying to turn around and say, population is your common response here. Can you pick it out of the question? I'm going to put a circle around D at this moment in time. More stray cats are reported because people are no longer careful about keeping their cats properly. That's just an opinion, no mathematical fact whatsoever. And again, I don't think there is a chance occurrence. As populations grow, people will be bringing in more pets, there will be more cats, there'll be more dogs, they will escape, there will be more strays. And so as far as I'm concerned, D is my correct answer. Did you notice what I did there? I eliminated section by section by section. Now, in the pressure of an exam, it's not always that easy. You have to just try and be as calm as you possibly can. Don't spend too long on the question, but reason it through. There is a strong positive association between a country's HDI, it's this question again, I did this at the end of the last video, and its carbon dioxide emissions. From this table it can be concluded that, well, the previous answer was actually D. The reason I want to talk about this question is part C here, because they try to throw a curveball in here. This association must be a chance occurrence and can be safely ignored. The minute we see the word chance, I know I'm talking about causality, causation, this type of topic. And again, you just have to think about, is there just a complete chance? Like the butter and the weddings or the divorces, that's a chance. But theoretically, as the Human Development Index goes up, there could be every chance that it would have some sort of relationship with carbon dioxide. And there we go, ladies and gentlemen, the end of correlation and causality. Thank you very much once again for watching. If you haven't already done so, can you subscribe by clicking the doohickey and spread the word? There are more videos being loaded every single day on here at YouTube, Maths Guru, and the world. I hope you're safe. I look forward to seeing you in our next video. Take care. Bye-bye.